Hello, my fabulous chemistry minions. This should be video number 7, should be the last video of ionics. So let's keep our fingers crossed on that. Today we're going to get into the properties. So because it's an ionic bond, how is it going to behave? What are its properties, its distinguishing features? This is what lab will be about partially. So they are very hard crystalline solids. Think of salt, table salt. Very high melting points and boiling points. So that is code MP's melting point, BP boiling point. You cannot get, and neither can I, table salt to melt at home. I'm thinking our stove tops can get to 560, 600 degrees Fahrenheit. We need to get into the 750, 800 degrees Celsius to get table salt to melt. So I can't do it. Maybe with an acetylene torch, but even that's going to be very difficult. They are mostly soluble, and then they form conductive solutions. So here's the other big one. So metals were very distinguishable because they were conductive of electricity. Ionics are going to be very distinguishable because when I put them into water and dissolve them, they will conduct electricity, and we will be able to see, we'll be able to differentiate that very, very much. Solubility has to do with, this is a rule that's foreshadowing for future lessons, but like dissolves like is the rule. Metal and a non-metal is polar by nature, so we're going to get into polar later in this unit, but that's that plus minus side. So like on a battery, there's a plus side and a minus side. So if there is a plus side and a minus side, then it is considered polar by nature. So North Pole, South Pole, that kind of thing. So it has to do with that. Water is very polar. So for the most part, polar solids will dissolve in polar liquids, which is water, and ionics are mostly polar. So hence, there's just a long way of getting around to the fact that, guess what? Ionics generally dissolve in water. Generally. Okay? Conductive solutions. Non-conductive in the solid form. So solid salt will not conduct electricity. But if I dissolve it, it does something special. What it does is it's called dissociation. So the Na and the Cl minus ions will separate from each other, which is a step past dissolve, which covalence won't do. So they dissociate into their actual ions, leaving them to float around. And then when they float around, calcium or chlorine ions are negative. There's always going to be a positive and a negative. So it doesn't matter which the ionic is. If it dissolves, there will be a negative ion in solution. The electricity that we hit it with will not know the difference between that negative ion and an actual just plain electron. Okay? So these mobile ions now move around, allowing the solution to conduct electricity. Melting point, the positive minus nature of ionics, very strong intermolecular forces. Again, foreshadowing to later in the unit. Forces between molecules. So NaCl, and then there's another NaCl. Well, that the negative side of this, the Cl, is going to line up with the positive side of the Na, and it's going to three-dimensionally, that negative Cl is going to be surrounded on all 6 sides by a positive Na, and vice versa. The Nas are going to be surrounded on all 6 sides by a negative Cl, and it's going to lead to this very, very high melting and boiling point. Okay, therefore, I need more energy to break them apart, hence higher melting point, higher boiling point, higher temperature, which I get those things to happen. This crystal lattice is what's formed. This is that plus minus, and there's a picture in here somewhere. I'm going to show you what that looks like. It not only affects the melting and boiling point, but it does make it extremely hard. So this is like when we did diamonds and graphite, the way the carbon atoms in diamond arranged was more of this crystalline lattice. And I know somebody asked me, well, what do we mean about this crystal business? Well, it has to do with that 3-dimensional piece. And I'm sure in the picture, there was a picture in vocab about with the green and the purple, the green chlorine and the purple sodium. We'll get to see it at some point. I'll make sure we see it. They fracture or cleave if you put them under enough pressure. So they do break, but differently. And with that, we got the properties of ionics down. Make sure you do your practice, guys. This is a practice heavy unit.